What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about wireless network attacks such as evil twins, rogue access points, bluesnarfing, bluejacking, disassociation, jamming, RFID attacks, NFC attacks, and initialization vectors. Let's talk about an evil twin. So an evil twin, this is a fraudulent Wi-Fi access point that appears to be legitimate, but is set up to eavesdrop on wireless communications. The evil twin is the wireless LAN equivalent of the phishing scam. This type of attack may be used to steal the passwords of unsuspecting users, either by monitoring their connections or by phishing, which involves setting up a fraudulent website and luring people there. The attacker snoops on internet traffic using a bogus wireless access point. Unwitting web users may be invited to log into the attacker's server, prompting them to enter sensitive information such as usernames and passwords, and often users are unaware they have been duped until well after the incident has occurred. Next, we have a rogue access point, and this is a wireless access point that has been installed on a secure network without explicit authorization from a local network administrator, whether added by a well-meaning employee or by a malicious actor. And to prevent the installation of rogue access points, organizations can install wireless intrusion prevention systems to monitor the radio spectrum for unauthorized access points. Next is bluesnarfing. So bluesnarfing, this is the unauthorized access of information from a wireless device through a Bluetooth connection, often between phones, desktops, laptops, and PDAs. This allows access to calendars, contact lists, emails, and text messages. And on some phones, users can copy pictures and private videos. Bluejacking exploits others' Bluetooth connections without their knowledge. Any device with its Bluetooth connection turned on and set to discoverable may be susceptible to bluesnarfing if there is a vulnerability in the vendor software. By turning off this feature, the potential victim can be safer from the possibility of being bluesnarfed, although a device that is set to hidden may be bluesnarfable by guessing the device's MAC address via a brute force attack. Next, we have bluejacking, and this is a hacking method that allows an individual to send anonymous messages to Bluetooth-enabled devices within a certain radius. First, the hacker scans his surroundings with a Bluetooth-enabled device, searching for other devices. The hacker then sends unsolicited messages to the detected devices. Bluejacking does not involve device hijacking, despite what the name implies. The bluejacker may send only unsolicited messages. Hijacking does not actually occur because the attacker never has control of the victim's device. At worst, bluejacking is an annoyance. Bluejacking can be prevented by setting a device to hidden, invisible, or non-discoverable mode. Next, we have disassociation attacks, also known as deauthentication attacks. So a Wi-Fi deauthentication attack, this is a type of denial of service attack that targets communication between a user and a Wi-Fi wireless access point. Unlike most radio jammers, deauthentication acts in a unique way. The IEEE 802.11 Wi-Fi protocol contains the provision for a deauthentication frame. Sending the frame from the access point to a station is called a sanctioned technique to inform a rogue station that they have been disconnected from the network. An attacker can send a deauthentication frame at any time to a wireless access point with a spoofed address for the victim. The protocol does not require any encryption for this frame, even when the session was established with WEP for data privacy, and the attacker only needs to know the victim's MAC address, which is available in the clear through wireless network sniffing. One of the main purposes of deauthentication used in the hacking community is to force clients to connect to an evil twin access point, which can then be used to capture network packets transferred between the client and the access point. The attacker conducts a deauthentication attack to the target client, disconnecting it from the current network, thus allowing the client to automatically connect to the evil twin access point. Next is jamming. So jamming is the deliberate jamming, blocking, or interference with wireless communications. In some cases, jammers work by the transmission of radio signals that disrupt communications by decreasing the signal-to-noise ratio. In a lot of instances, the jamming of wireless signals are used to create a full or partial DOS condition in the wireless network. Most modern wireless implementations provide built-in features that can help immediately detect jamming attacks. attacks. Next, we have RFID attacks. So RFID, it uses electromagnetic fields to automatically identify and track tags attached to objects. An RFID tag consists of a tiny radio transponder, which is a radio receiver and transmitter combined together. When triggered by an electromagnetic interrogation pulse from a nearby RFID reader device, the tag transmits digital data, usually an identifying inventory number, back to the reader. This number can be used to inventory goods. RFID attacks, they can come in the form of skimming, on-path attacks, sniffing, eavesdropping, replaying, spoofing, and jamming, which is a form of a DOS attack. From an authentication standpoint, the attacker uses the attacks to try to find out the passcode. An RFID tag can also be reverse engineered if the attacker gets possession of it. Also, power levels can be analyzed to find out passwords because some RFID tags emit different power levels when it comes to correct and incorrect passcodes. To prevent RFID attacks, security administrators should consider newer generation RFID devices, encryption, chip codings, filtering of data, and multi-factor authentication methods. Next, we have an NFC attack. So near field communication, this is a set of communication protocols that enable two electronic devices, one of which is usually a portable device, such as a smartphone, to establish communication by bringing them within 4 centimeters of each other. Although it is rather difficult to attack an NFC-enabled device due to the distance NFC devices have to operate within, there are 3 methods that can be used against NFC technology, such as eavesdropping, and this is where the attacker could use an antenna to record communication between NFC devices. You have data modification. This is where data that's being exchanged can be captured and modified by an attacker's radio frequency device. And then you have a relay attack. This is where an attacker holds an NFC reader near the victim's NFC device and relays data over another communication channel to a second NFC reader placed in proximity to the original reader that will emulate the victim's NFC device. And then we have an initialization vector. So an initialization vector, this is a random fixed size input that occurs in the beginning of every WEP or WPA packet. The initialization vector is typically required to be random or pseudo-random, but sometimes an IV only needs to be unpredictable or unique. Randomization is crucial for some encryption schemes to achieve semantic security, a property whereby repeated usage of the scheme under the same key does not allow an attacker to infer relationships between segments of the encrypted message. Initialization vector attacks are wireless network vulnerability attacks. An IV attack is a type of related key attack which occurs when an attacker observes the operation of a cipher using several different keys and finds a mathematical relationship between those keys, allowing the attacker to ultimately decipher data. The best way to prevent IV attacks is to use stronger wireless protocols such as WPA2 with AES encryption and WPA3. All right, so that was my quick little class on wireless network attacks. So let's go ahead and get to some of this wonderful check on learning. So first question is, gaining unauthorized access to a Bluetooth device is referred to as what? Would this be disassociation, bluejacking, jamming, or bluesnarfing? So an unauthorized access to a Bluetooth device, this is known as what? And the correct answer is, this will be known as bluesnarfing. Next question. Wireless jamming is what type of attack? Is this an RFID attack, a DOS attack, a brute force attack, or a downgrade attack? So wireless jamming, this is known as what type of attack? And the correct answer is, this will be a denial of service attack. Next question. RFID is vulnerable to which type of attack? Would this be spoofing, eavesdropping, replay attacks, or all of the above? So RFID is vulnerable to which one of these attacks? And the correct answer is, this will be all of the above: spoofing, eavesdropping, and replay attacks. All right, so in summary, we have talked about wireless network attacks such as evil twins, rogue access points, bluesnarfing, bluejacking, disassociation, jamming, RFID attacks, NFC attacks, and initialization vector attacks. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get ready read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.